we know that the derivative gives us the slope of the tangent line of a function at a particular point. So the derivative can actually give us a lot of information about what a function looks like graphically. Let's take a look at an example of that. So suppose that our function is x cubed minus 12x squared plus 36x minus 16. And it is easy enough for us to calculate that the derivative is 3x squared minus 24x plus 36, which I'll note that factors as 3 times x minus 6 times x minus 2. So what I'm going to do now is that I'm going to plot, draw a graph of f of x and draw a graph of f prime of x, and we'll see how those compare and see what the information about the derivative tells us. So what does f of x look like? So here is a set of axes. Let me put some tick marks here. So 2, 4, 6, 8. And so the function looks something like this. So it's not a perfect picture, but it's taking care of the important things here. So this is what the function looks like. So let's remember that when the derivative is positive, so this means that the slope of the tangent line is positive, so our function is increasing. If the derivative is negative, the slope of the tangent line is negative, so the function is decreasing. So taking a look at our f prime of x, and I should say here, f prime, there's a leftover case here. What happens if the derivative is 0? The slope of the tangent line is 0, which means we have a horizontal tangent line. So let's take a look. What information do we have here about the derivative? Well, we see the derivative here is 0 when x is 6 or when x is 2. Well, guess what? Derivative of 0, that's when the slope of the tangent line is 0. That's when we have a horizontal tangent line there and there, which is exactly corresponding to x is equal to 2 and x is equal to 6. Exactly as we'd expect. If x is between 2 and 6, our tangent lines are going to be negative. So in here, f prime of x is negative. We can see that from looking at the factored form of f prime of x. If x is between 2 and 6, x minus 6 is negative, x minus 2 is positive, positive times positive is negative. Our function is decreasing there. Over here and over here, our function is increasing. The slopes of the tangent line are positive. We can see that if x is bigger than 6, x minus 6 is positive, x minus 2 is positive, 3 is positive, 3 positives make it positive. If x is less than 2, x minus 2 is negative, x minus 6 is negative, positive times negative is positive. So here's a graph of what our function looks like. We can graph what does the derivative look like. The derivative, so 2, 6, the derivative looks something like this. So the derivative is negative until it hits 2. the derivative is positive until it hits 2, which corresponds to the function is increasing. It's negative between 2 and 6, which corresponds to the function is decreasing. It's positive bigger than 6, which corresponds to the function is increasing. I'm stealing this example straight from the textbook. If you want to see a slightly more carefully drawn graph, you can take a look at it right there in section 3.2. So the derivative gives us lots of information about the behavior of a graph. One interesting little exercise we can do is what happens, I can just draw you a picture of the graph without giving you a formula for it. If I draw you a picture of the graph, you should be able to draw me a picture of what the derivative looks like. So the last example for this video here. So here is a sketch of a function, and I'm going to do my best to, again, I'm stealing this example straight from the book. I'm going to do my best to mimic what's going on in the picture. So let's see, there. Oops, it's supposed to bottom out at 7, so that is the best I can do. So here's a graph of the function. Let's call this f of x. So let's have some kind of sketch for f prime of x. And again, I guess I will label this 1, 4, and 7. So let's see. First, if we're trying to sketch the derivative, we should be looking for where can we find horizontal tangent lines. Well, there's a horizontal tangent line there. There's a horizontal tangent line there. There's a horizontal tangent line there. That's presented, it's drawn accurately enough that that's matching up with 1, 4, and 7. So at each of these points, these horizontal tangent lines tell us that the derivatives there are 0. So if I'm drawing f prime of x, it has to go, f prime of x has to pass through 1, 4, and the 0. There have to be zeros at 1, 4, and 7. Okay, between 1 and 4, the slopes of the tangent line are positive, which means the derivative here has to be positive, which means our derivative is above the x-axis. Between 4 and 7, the slope of the tangent line is negative, the function is decreasing, the derivative is negative. So between 4 and 7, I have to draw the slope, draw the derivative to be under the x-axis. And then it doesn't take too much to, we can similarly see over here the function is increasing, which is a positive derivative. And over here, the function is decreasing, the tangent line has negative slope, the derivative is negative. And so here is a sketch, a rough sketch, but a pretty useful one, all things considered, of what if I give you a sketch of the original function, look at how much we can do. We can sketch a pretty good picture of its derivative.